Hi there, we're looking at arithmetic sequences, and you'll notice that this video is called Using the Formulae 2. So if you're looking at starting with core 1 sequences, then I'd suggest you go back and watch the basics where I introduced the 2 formulae, and I've got a previous video where I apply the formulae to a more practical problem of John running. So this one is a more algebraic effort where the sequence is in terms of k, and we're asked to find a couple of things related to that. So as with any sequences question, you'll want to start by finding the first term, which is k, the difference. Now in this case it's not too hard to spot that the difference is k, but if you're unsure you can always do one term, take away the previous term to find the difference, and just to confirm that that's k. And the number of terms we don't know because that's what we're asked to find. But what we do know is that the last term has a value of 100. So if we use our formulae for the nth term, we know that the term value is 100, and we've got the first term and the difference. And if we apply that in the formula, you end up with k plus k times n minus k, which means that 100 is equal to k times n, and with a bit of rearranging you can see that n is equal to 100 over k. So that's how we've managed to find in terms of k an expression for the number of terms in this series. So we applied what we did know about it, a particular term value in the individual term formulae. For the second part it says show that the sum of the series is. So as soon as it says that, you'll need to recall your formulae for the sum of an arithmetic series. You need to be able to derive this, and I've got a video showing you how to do that if you need to know that. Now in this case we've got our n now from the first part, which is 100 over k. If you divide that by 2, you get 50 over k. 2 lots of the first term is 2k. N is 100 over k. I'm going to take 1 away from that and then times it by the difference, which is k. Give myself a bit more room. Multiplying out these brackets first, you'll end up with 100, because the k's will cancel, multiplied by k, and we're going to add 2k to that and times it by 50 over k, which will give us k plus 100 in the bracket. And once we multiply that by 50 over k, we end up with 50 plus 5,000 over k, which is what we're asked to show. So in this question, you've had to use the individual term formulae and the sum, and it's just started as always with finding a and d and if possible n. And every question, if you start the same way, you've got a good chance of getting the marks.